Hello everyone, we are still continuing our fraction unit this week and we are focusing on part of a whole and also line plots with fractions. So a quick example of an easy one for part of a whole would be half of 6. The kids are going to be able to determine half of 6 pretty quickly, knowing that that would be 3. So you have a visual here. Another way without just knowing what half of 6 is determining the fact that you're finding an equivalent fraction, because a half and a 6 have different wholes here. Okay, so if I want to go from halves and I want to move over here to sixes, how do I do that? Well, 2 times 3 gives me 6, therefore 1 times 3 gives me 3. So again, half of 6 is 3, 6. If I were to look at 5/6 of 24, okay, this is out of 24 pieces. Here I'm dealing with sixes. So how am I going to get there? And we know that 5/6 is almost one whole. So it's going to be close to 24. So we look at it and we set it up. 6, I'm trying to get to 24. How do I get there? 6 times 4 gives me 24. Therefore, 5 times 4 gives me 20. So 5/6 is really 20 24ths, okay? And so the answer would be 20. What is 5/6 of 24? 20. If I look at 3/8 of 56, so I'm trying to go from 8s over here to 56. How do I do it? Well, 8 times 7 gives me 56. Therefore, 3 times 7 gives me 21. So what's 3/8 of 56? 21 is. So the kids have a very good understanding of equivalent fractions at this point. And they also have a very good understanding of what numbers to multiply to get to that common whole or that denominator. So I really don't think the kids will have too many issues with part of a whole. The next thing that we're going to talk about this week and on into next week are line plots with fractions. So the kids have already done line plots this year when they focused on Unit 4 when we did data collection. We may have done 1 or 2 that had fractions, so they've been exposed to it back in that unit, but we're really focusing in this unit on line plots with only fractions. So, just kind of a recap on how to read them. Anytime you have the numbers, and in this case you've got the fractions and you have the mixed fractions, I always tell the kids whatever the title is of the line plot, that matches your numbers, okay? So these are weights of Pepper's puppies in pounds. So these are all the weights of, in pounds of the puppies. So what do the X's mean? The X's are going to represent your puppies. Okay. So one question that I could take from this line plot is 2 puppies weighed the same amount. What was the total of the 2 puppies? So the kids are going to recognize that, okay, the X's are the puppies. Here are 2 puppies that weighed the same amount, 3/4 of a pound. They already know how to add because we just finished this, this skill. So 3/4 plus 3/4 equals 6/4. Okay, so remember again, we are not adding our denominator because we're not changing the whole. These are out of fourths. So because I have 6/4, the kids can then take this improper fraction and convert it. Okay, because at this point they know how to do that. If I convert it, I'm going to get 1 2/4, or some of my kids may say 1.5 pounds if they've reduced it. Another question I can ask is how much more did the heaviest puppy weigh than the lightest puppy? Okay, so I'm not talking about how much more did the most puppies have, okay, because you would think, okay, the most puppies are 3/4. I'm asking the heaviest puppy weigh. If I'm talking about the heaviest puppy, I'm looking at 1 pound, okay, because that's the heaviest in pounds. So I'm at 1 pound here. And I'm looking at the lightest puppy. The lightest puppy weighed 1/8 of a pound, okay? So when I subtract 1, or that's 8/8, okay, because we're dealing with 8s here, okay? So if I take 1 or 8/8 and I subtract 1/8, what am I going to have left? 7/8. So there's a 7/8 pound difference between your heaviest, that was a pound, and your smallest, which was 1/8 of a pound, okay? Another question, what is the outlier? So we've talked about it's out and it lies away from the rest of the data. So if you look at the data, it's really focused and concentrated right here between 5/8 and 1 whole, okay, or 1 pound. And then you have this 1/8 that's kind of out and lies away from the rest of the data. So in this line plot, 1/8 would be considered the outlier. Another question that students might be asked when looking at line plots is total. What is the total? So in this case, I could ask what are the total pounds, okay, for these puppies? All right, and so if I walk you through this, remember the X's matter. How many there are really matters. So there's one puppy that weighed 1/8. There's another puppy that weighed 5/8. There are 2 puppies that weighed 3/4, so I have to add those 2. Another puppy that weighed 7/8, and then another puppy that weighed 1 pound, okay? So some of you might be looking at, if I add them up, there are 8s and then there are 4ths, okay? So you're like, well, what do we do with these 4ths and these 8s, okay? Because these are unlike denominators. The kids have been practicing how to add and subtract unlike denominators, okay? So they are going to be able to recognize that 3/4, knowing their skill of equivalency, that 3/4 really is the same thing as me saying 6/8. Okay, so the kids are going to change 3/4 over to 6/8. So then they're going to add 1/8, 5/8, 6/8, 6/8, 7/8, and then 1 pound. And when they do, they'll get 1 and 25/8. Okay, and at this point, the kids will convert their 25/8 over, okay, and then they will add that back to their 1 pound. And their final answer would be 4 and 1/8 pounds for the total amount of pounds on this entire line plot. Okay, so again, it's the same thing that they did with line plots with regular whole numbers. This time we're just dealing with fractions. So with line plots with fractions, the students are going to be able to practice their skill of equivalent fractions because they may recognize that not all of the denominators are of the same whole. So they're going to have to know that skill of equivalency. They're going to practice adding and also subtracting fractions. So everything that they've been taught so far, they'll be able to apply to the graph. Okay? I hope this has been helpful, and if you have any questions, please feel free to email me. Thanks so much.